Now let's go through exercise 11.2. First question. Show that the three lines with the direction cosines 12 by 13 minus 3 by 13 minus 4 by 13, 4 by 13, 12 by 13, 3 by 13, 3 by 13 minus 4 by 13, 12 by 13 are mutually perpendicular. Okay. See here we have studied that how to find the angle between two lines when their direction cosines are given, right? We studied that L1, if L1, M1, N1 and L2, M2, N2 are the direction cosines of two lines, then cos theta is equal to L1, M1 plus, L1, L2 plus M1, M2 plus N1, N2, right? Cos theta is equal to L1, L2 plus M1, M2 plus N1, N2. Here we have to show here three lines, right? So direction cosines of three lines are given. Okay. We have to prove these three lines are mutually perpendicular. Means their angles 90 degree. Right? So here for 90 degree, that is theta is equal to 90 degree. What is cos 90? 0. Right? So here it is enough to prove that L1, L2 plus M1, M2 plus N1, N2 is equal to 0. Okay. So here let's take two lines. Okay. First of all, let's take these two lines. Okay. And we have to prove these two lines are perpendicular. That means theta is equal to 90 degree. That is cos theta is equal to 0. Cos 90 is 0. So here we have to show L1, L2 plus M1, M2 plus N1, N2 is equal to 0. Next we will take these two lines, okay, and after that these two lines. So here for every pair of lines, so here we have to prove L1, L2 plus M1, M2 plus N1, N2 is equal to 0. Okay. See here first of all let's consider these two lines. Okay. Here L1, M1, N1, L2, M2, N2 are the direction cosines. Then here we have to show these two lines are perpendicular, that is theta is equal to 90 degree. Therefore we have to show L1, L2 plus M1, M2 plus N1, N2 is equal to 0, right? Okay. So here L1, L2 plus M1, M2 plus N1, N2 is equal to, okay, consider these two lines. So 12 by 13 into L2. 4 by 13 plus M1 minus 3 by 13 into 12 by 13 plus minus 4 by 13 into 3 by 13. Okay. That is equal to, here 12 into 4, 48. Denominators are same, right? Okay. So 48 minus 36 minus 12 divided by 13 square is 169. Okay. That is equal to, see 48, yes, 48 minus 36 minus 12 minus 48 plus 48, that is 0. Okay. So here we have considered these two lines, right? Okay. And we have got L1, L2 plus M1, M2 plus N1, N2 is equal to 0. That means cos theta is equal to 0. Cos theta is equal to 0 implies theta is equal to 90 degree. Okay. That means these two lines are perpendicular. Okay. These two lines are perpendicular. Next let's consider these two lines. Okay. So here L1, M1, N1, L2, M2, N2. Okay. Consider these two lines. See, you have to write these two lines. Okay. Direction cosines of these two lines. Then write L1, L2 plus M1, M2 plus N1, N2 is equal to 14 by 13 into 3 by 13 plus 12 by 13 into minus 4 by 13 plus 3 by 13 into 12 by 13. That is equal to, here it is 42 minus 48 plus 36 divided by 169. Sorry, it is not 14, 4, okay, 4. So 12. That is equal to, see, 12 plus 36, 48, 48 minus 48, so it's also 0. Right? So here we have got, that is L1, L2 plus M1, M2 plus N1, N2 is equal to 0 from these two lines. Okay. That means cos theta is equal to 0. Therefore, theta is equal to 90 degree. Therefore, we can say these two lines are perpendicular. Okay. Next, one more line, that is these two lines. Okay. So here L1, M1, N1, L2, M2, N2. Okay, next we will find L1, L2 plus M1, M2 plus N1, N2 is equal to, here 12 by 13 into 3 by 13 plus minus 3 by 13 into minus 4 by 13, okay, plus minus 4 by 13 into 12 by 13. That is equal to 36 by 13 minus, sorry, it is plus 12 by 13 minus 48 by 13. Sorry, it is 169, right? Yes. 13 into 13, 169. 169. That is equal to, see here, 36 plus 12, 48, 48 minus 48, it's also 0. So here also, see, when we take this pair also, we have got this L1, L2 plus M1, M2 plus N1, N2 is equal to 0. That means cos theta is equal to 0. That means angle between these two lines is 90 degree. Therefore, here we can say these three lines are mutually perpendicular. Okay. Look at the next question. Show that the line through the points 1, minus 1, 2, 3, 4, minus 2 is perpendicular to the line through the points 0, 3, 2 and 3, 5, 6. Okay. Here two lines and 2 points on the two lines are given. Okay. 2 points on the first line and 2 points on the second line are given. Here we have to show these two lines are perpendicular. Okay. That means we have to show that it's 90, that is theta is equal to 90 degree. That is cos theta is equal to 0. Right. And we have a formula, cos theta, that is angle between two lines, is cos theta is equal to A1, A2 plus B1, B2 plus C1, C2 divided by modulus of A1 square plus B1 square plus C1 square root of A2 square plus B2 square plus C2 square. It is the formula, right? So here we have to show these two lines are perpendicular. For that, see, if two lines are perpendicular, what is cos theta? Cos theta is 0, right? Because cos 90 is 0. So we have to prove this one is equal to 0. That is, we have to prove this numerator is equal to 0. So here for this perpendicular, we have to show A1, A2 plus B1, B2 plus C1, C2 is equal to 0. Then we can say these two lines are perpendicular. Okay. So how to find A1, A2? What are the A1, B1, A2, A1, B1, C1, A2, B2, C2? Are the ratios, that is direction ratios of two lines. Right. So let's find direction ratios of these lines. Okay. That is A1, B1, C1. So how to find? How to find direction ratios of lines? See, it is x1, y1, z1, x2, y2, z2 are the points on the line. Then direction ratios of this line is nothing but x2 minus x1, y1, y2 minus y1, z2 minus z1. Okay. So let's find A1, that is x2 minus x1, that is 3 minus 1, okay, is equal to 2, and B1 is equal to 4 minus minus 1, 5, and C1 is equal to minus 2, that is minus 4. And A2 is equal to next, okay, next line, direction ratios of next line. So here 2 points on the line are given, okay. So x1, y1, z1, x2, y2, z2. Direction ratios are x2 minus x1, that is A2 is equal to 3 minus 0, 3. B2 is equal to 5 minus 3, 2. And C2 is equal to 6 minus 2, 4. Okay. So remember how to find direction ratios of a line when 2 points on the line are given. Okay. See here, these are 2 points on the line, x1, y1, z1, x2, y2, z2. How to find the direction ratios? x2 minus x1, okay, y2 minus y1 and z2 minus z1 are the direction ratios of the line. Okay. Okay. See here we have got direction ratios of these two lines. Now we have to prove a1, a2 plus b1, b2 plus c1, c2 is equal to 0. Then we can say cos theta is equal to 0. If cos theta is equal to 0, theta is equal to 90 degree. That means these two lines are perpendicular. Okay. So here what is a1, a2 plus b1, b2 plus c1, c2. a1, a2. That is a1, 2. 2 into 3 plus 5 into 2 plus minus 4 into 4. That is equal to 2 into 3, 6 plus 10 minus 16 is equal to minus 16 plus 6 minus 10 plus 10 0. See, here we have got a1, a2 plus b1, b2 plus c1, c2 is equal to 0. So if you substitute it is equal to 0, you will get cos theta is equal to 0. Cos theta is equal to 0 implies theta is equal to 90 degree, right? Therefore, here given two lines are perpendicular. Next question, show that the line through the points 4, 7, 8, 2, 3, 4 is parallel to the line through the points minus 1, minus 2, 1, 1, 2, 5. Okay, so here 2 points on the two lines are given, right? Here we can find direction ratios of these two lines. And here we have to prove these two lines are parallel. Okay, so how to prove? See, suppose vector r1 is equal to vector a1 plus lambda vector b1 and vector r2 is equal to vector a2 plus mu vector b2 are the two lines. Okay, and here we know that vector r1 is parallel to vector b1, right? And vector r2 is parallel to vector b2. Okay, so here we have to prove vector r1 is parallel to vector r2. That is, these two lines are parallel. Okay, so suppose vector r1 parallel to vector r2. Then what about vector b1 and vector b2? They are also parallel, right? Because vector r1 is parallel to vector b1, vector r2 parallel to vector b2. Okay, b2 is the vector parallel to r2. Therefore, here we can say vector b1 and vector b2 are parallel vectors. Okay, here suppose a1, b1, c1 are the direction ratios of first line. Okay, and a2, b2, c2 are the direction ratios of second line vector r2. Okay, then vector b1 is equal to a1i b1j plus c1k. Vector b2 is equal to a2i plus b2j plus c2k, right? Okay, and here we have vector b1 parallel to vector b2. We know that, suppose see, it is vector a and it is vector b. Okay, here we can write vector b is equal to lambda vector a because they are parallel. Okay, so here also we can write vector b is equal to lambda vector b2. Okay, because like vector b1 is equal to lambda vector b2 because they are parallel. Okay, so here vector b1 is equal to lambda vector b2. Okay, that is, what is vector b1? a1i plus b1j plus c1k. that is equal to lambda into a to I plus b to j plus c to k. Okay. Now here compare coefficients of corresponding components. Okay. So we will get, see here, coefficient of I in LHS is A1 and in RHS lambda A2. Okay. Next compare coefficient of J on both sides. B1 is equal to lambda B2. C1 is equal to lambda C2. Right? So here from this we will get A1 by A2 is equal to lambda, B1 by B2 is equal to lambda, C1 by C2 is equal to lambda. Right? See, all are lambda, right? Therefore, this can be written as A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Okay? So, for parallel vectors or parallel lines, here we have to show the direction ratios are proportional. Okay? If direction ratios of two lines are proportional, then we say given two lines are parallel. Okay? So, here what we have to prove? We have to prove A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Okay? See here, if two lines are parallel, then their direction ratios of these two lines are proportional. Okay? So, here we have to prove A1 by A2 is equal to B1 by B2 is equal to C1 by C2. What are A1, B1, C1, A2, B2, C2? They are the direction ratios of the lines. Here only 2 points on the lines are given. Right? So, here first line, 2 points on the first line are 4, 7, 8, 2, 3, 4. We can find direction ratios from these points. Right? Okay. So, first of all, let's find A1. Direction ratios. Suppose x1, y1, z1, x2, y2, z2 are the 2 points on the line. Then, what are the direction ratios? x2 minus x1, right? So, A1 is equal to 2 minus 4, that is minus 2. B1 is equal to 3 minus 7 minus 4. C1 is equal to 4 minus 8 minus 4. Okay. Next, these are the direction ratios of first line. Okay. Next, here 2 points on the another line are given, minus 1, minus 2, 1, 1, 2, 5. So, here A2 is equal to x2 minus x1, that is 2, 1 minus minus 1, 2. Okay. And B2 is equal to 2 minus minus 2, 4. C2 is equal to 5 minus 1, that is 4. Okay. Now, let's find this. A1 by A2 is equal to, what is A1 by A2? Minus 2 by 2, that is minus 1. B1 by B2 is equal to minus 4 divided by 4, that is also minus 1. And C1 by C2 is equal to minus 4 divided by 4, that is also minus 1. Okay. So, here we have got A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Therefore, given these two lines are parallel. Next question, find the equation of the line which passes through the point 1, 2, 3 and is parallel to the vector 3i plus 2j minus 2k. See, here we have already learnt that find the equation of a line when a point on the line and parallel vector are given. Okay. So, here see, same thing, a point on the line and parallel vector are given. So, what is the equation of the line? Vector R is equal to vector A plus lambda vector B. Here, vector A is the position vector of a point on the line. Okay. And vector B is the parallel vector. Okay. So, let's find what is the position vector. That is vector A is equal to I plus 2j plus 3k. Okay. Vector A is the position vector of a point on the line. And vector B is equal to 3i plus 2j minus 2k. Okay, now let's substitute these vectors in this equation. Therefore, vector R, what is vector R? Equation of the line. Okay. So, vector R is equal to vector A is I plus 2j plus 3k plus lambda into 3i plus 2j minus 2k. That is here 1 plus 3 lambda I plus 2 plus 2 lambda j plus 3 minus 2 lambda k. So it is the vector equation of a line. Find the equation of the line in vector and Cartesian form that passes through the point with the position vector 2i minus j plus 4k and is in the direction I plus 2j minus k. See here we have to find the equation of the line, and it is mentioned that vector equation and Cartesian equation. Okay. So okay, here what are given? See, position vector of a point is given. Okay, position vector of a point 2 minus 1 4. Okay, point on the line is 2 minus 1 4. And parallel vector is I plus 2j minus k. Okay. See here we have vector equation of a line is vector R is equal to vector A plus lambda vector B. Right. What is vector A? Vector A is a position vector of a point. Right. Here it is given position vector. Okay. So position vector and vector B is nothing but parallel vector. Right. So here vector A is equal to 2i minus j plus 4k and vector B is equal to I plus 2j minus k. Okay. Then vector R is equal to vector A, that is 2i minus j plus 4k plus lambda into I plus 2j minus k. Okay. So here it is the vector equation, or you can write it as 2 plus lambda I plus minus 1 plus 2 lambda minus 1 plus 2 lambda j plus 4 minus lambda k. Okay. So here it is the vector equation of the required line. Okay. So next we have to write the Cartesian equation. Okay. That is equation of a line in Cartesian form. Here we know that what is the equation, Cartesian equation? X minus x1 divided by a, that is equal to y minus y1 divided by b is equal to z minus z1 divided by c. See, if you forget this Cartesian equation, you just substitute what is r. Substitute r is equal to xi plus yj plus zk. Then equate corresponding coefficients of components, you will get the Cartesian equation. Okay. So, or you can directly substitute here x1, y1, z1 is a point on the line and ABC are the direction ratios of the line. Okay. So, here what are the points? So, what is a point on the line? x1, y1, z1 is nothing but, see, it is the position vector of a point. Right. What is the point? 2 minus 1, 4. So, here x1, y1, z1 is equal to 2 minus 1, 4. And ABC are the direction ratios of the line. Right? ABC are the direction ratios of the line, that is parallel vector. Okay. So, here it is nothing but AI plus BJ plus CK. Right? So, ABC are 1, 2, minus 1. Okay. A is equal to 1, B is equal to 2, C is equal to minus 1. Then substitute here. So, Cartesian equation of a line is x minus x1, x minus 2 divided by a1, that is equal to y minus y1, that is y plus 1, y minus minus 1, y plus 1 divided by b2, that is equal to z minus z1, z minus z1 is 4 divided by minus 1. So it is the Cartesian equation of the line. And the vector equation is vector r is equal to 2 plus lambda I plus minus 1 plus 2 lambda j plus 4 minus lambda k. If you substitute vector r is equal to xi plus yj plus zk, then compare the coefficients of each components, okay, corresponding components, you will get the same Cartesian equation. Find the Cartesian equation of the line which passes through the point minus 2, 4, 5 and parallel to the line given by x plus 3 by 3 is equal to y minus 4 by 5 is equal to z plus 8 divided by 6. See here also similar question. Here a point on the line and parallel line equation is given. That equation is in Cartesian form, right? And here we have to find the equation of a line in Cartesian form, okay? Equation of a line on the point, a point on the line, that is line passes through a point is given and parallel line, okay, that is given. Okay, so here we will apply the same equation, vector r is equal to vector a plus lambda vector b, right? But here we have to write the equation in Cartesian form, okay? So let's write Cartesian form equation. Equation in Cartesian form, x minus x1 by a is equal to y minus y1 divided by b is equal to z minus z1 divided by c. So here what are x1, y1, z1? x1, y1, z1 is a point on the line, that is minus 2, 4, 5, right? x1, y1, z1 is equal to minus 2, 4, 5. Okay. And what are ABC? ABC are the direction ratios of this line. Okay. And this line is the parallel line. Okay. We have to find the equation of the line which is parallel to this line. Okay. So here in this line, see this equation, these 3, 5, 6 are nothing but direction ratios of this line. Okay. Since these lines are parallel, so direction ratios of required line is nothing but 3, 5, 6 itself. Okay, because these lines are parallel. So therefore, here A is equal to 3, B is equal to 5 and C is equal to 6. Okay, why? Because see, it is the parallel line and it is in Cartesian form. Here these 3, 5, 6 are nothing but direction ratios of this line. Okay, and these two lines are parallel. Therefore, direction ratios of this line is also 3, 5, 6. Okay. Now, so A is equal to 3, B is equal to 5, C is equal to 6. Now, let's substitute these values in this equation. Okay. See, if you forget this equation, then you just write a vector equation of the line, then substitute vector r is equal to xi plus yj plus zk, then compare the corresponding coefficients of components. Okay. So here that is x minus, required equation is x minus minus 2, that is x plus 2 divided by a 3, that is equal to y minus 4 divided by b 5, that is equal to z minus 5 divided by 6. See, it is the required Cartesian equation of the line. The Cartesian equation of a line is x minus 3 by 3 is equal to y plus 4 divided by 7 is equal to z minus 6 divided by 2. Write its vector form. Here equation of a line in Cartesian form is given. We have to write it in vector form. Okay. So what is the vector equation of a line? Vector r is equal to vector a plus lambda vector b. Okay. So first of all, let's compare this given equation with the general equation. That is Cartesian equation, x minus x1 divided by a is equal to y minus y1 divided by b is equal to z minus z1 divided by c. Here what are x1, y1, z1? A point on the line. A, B, C are the direction ratios of the line. So here point is x1, y1, z1, that is equal to 5 minus 4, 6, right? 5 minus 4, 6. Okay. Then next A, B, C direction ratios. A is equal to 3, B is equal to 7 and C is equal to 2. See here we have to write the vector equation, right? So vector r is equal to vector a. What is vector a? Position vector of a point on the line, right? And vector b is nothing but parallel vector. Okay, that is vector a is equal to position vector of point 5 minus 4, 6. That is 5i minus 4j plus 6k. And vector b is equal to parallel vector, and these are the direction ratios. So 3i plus 7j plus 2k is the vector b. Okay, now let's substitute this in this equation. Therefore, required vector equation of a line is vector r is equal to vector a 5i minus 4j plus 6k plus lambda into 3i plus 7j plus 2k. It is the vector equation of a line in Cartesian form. Find the vector and the Cartesian equations of the lines that pass through the origin and 5 minus 2, 3. See, here we have to find the equation of the line when 2 points on the line are given. Okay. See, what are the 2 points? One is origin, that is 0, 0, 0. And another one is 5 minus 2, 3. So, what is the vector equation of the line when 2 points on the line are given? Vector r is equal to vector a plus lambda into vector b minus vector a. Right? Here vector a and vector b are the position vectors of the points on the line. Okay. So here vector a is equal to, see, one point is origin, right? So vector a, let vector a be the position vector. Let vector a be the position vector of origin. That is 0, 0, 0. Okay. Therefore, vector a is equal to 0i plus 0j plus 0k. And vector b be the position vector of the point 5 minus 2, 3. Therefore, vector b is equal to 5i minus 2j plus 3k. Then substitute this vector a and vector b in this equation. Therefore, vector r is equal to vector a, that is 0 vector. Okay, it's 0. Next, lambda into vector b is 5i minus 2j plus 3k minus a, that is 0. Okay, so it is the vector equation of the line. Next, we have to write it in Cartesian form. Okay, so what is the equation? Cartesian equation of the line when 2 points on the line are given is x minus x1 divided by x2 minus x1 is equal to y minus y1 divided by y2 minus y1 is equal to z minus z1 divided by z2 minus z1. Substitute here x1, y1, z1 and x2, y2, z2 are the 2 points on the line. Okay, substitute x minus x1 is x1, y1, z1 is the origin 0, 0. So x minus 0 divided by x2 minus x1, that is 5 minus 0. That is equal to, okay, let's write 5 minus 0. Next, y minus y1, that is y minus 0 divided by y2, that is minus 2 minus 0. That is equal to z minus z1 0 divided by z2 is 3 minus z1 0. That implies x by 5 is equal to y by minus 2 is equal to z divided by 3 is the Cartesian equation of the line. Find the vector and Cartesian equations of the line that passes through the points 3 minus 2 minus 5, 3 minus 2 6. So here very simple, right? So directly substitute the values. Okay. Here we have to find the equation of the line when 2 points on the line are given. Okay. So what is the vector equation? Here we have to write the vector equation of the line in vector form and Cartesian form. So first of all, let's write vector equation. Vector r is equal to vector a plus lambda into vector b minus vector a. Right. So what are vector a and vector b? Position vectors of the points on the lines. Right. So here 2 points, 3 minus 2 minus 5, 3 minus 2 6. So vector a is equal to position vector of a point 3 minus 2 minus 5, that is 3i minus 2j minus 5k. And vector b, let vector a is equal to, vector b is equal to 3i minus 2j plus 6k. Okay. Then substitute vector r is equal to vector a, that is 3i minus 2j minus 5k plus lambda into vector b minus vector a. So 3 minus 3, 0. Minus 2 minus minus 2, that is also 0. 6 minus minus 5, that is 6 plus 5, that is 11k. Okay. So here 3i minus 2j minus 5 plus here we can write plus minus 5 plus 11 lambda k. So it is the vector equation. Okay, vector equation of the line. Next we have to write this equation of the line in Cartesian form, that is x minus x1 divided by x2 minus x1 is equal to y minus y1 divided by y2 minus y1 is equal to z minus z1 divided by z2 minus z1. Substitute x1 y1 z1 is 3 minus 2 minus 5 and x2 y2 z2 is 3 minus 2 6. That is x minus x1 3. Okay. Here x1 y1 z1 is equal to 3 minus 2 minus 5 and x2 y2 z2 is equal to 3 minus 2 6. Okay. Substitute the values of x1 y1 z1 x2 y2 z2. X minus 3 divided by x2 is 3. 3 minus 3, that is 0. That is equal to, next one is y minus y1. So y minus y1 is minus 2. So y plus 2 divided by y2 minus y1, that is also 0. That is equal to, next is z minus z1. Z minus z1 is, that is z plus 5 divided by z2 6. 6 minus minus 5, that is 11. So it is the Cartesian equation of the line. Find the angle between the following pairs of lines. See, first question, vector r is equal to 2i minus 5j plus k plus lambda into 3i plus 2j plus 6k, and vector r is equal to 7i minus 6k plus mu into I plus 2j plus 2k. Okay. So here two equations of two lines are given. Okay. And these equations are of the form vector r is equal to vector a plus vector a1 plus lambda vector b1, and vector r is equal to vector a2 plus mu vector b2. Right. So here we have studied that how to find the angle between these two lines. That is, let theta be the angle between two lines. Then cos theta is equal to vector modulus of vector b1 dot vector b2 divided by modulus of vector b1 into modulus of vector b2. It is the formula. Right? If theta be the angle between two lines, then cos theta is equal to modulus of because cos theta is positive. Okay, vector b1 dot vector b2 divided by modulus of vector b1 into modulus of vector b2. Okay, now let's substitute. What are vector b1 and vector b2? See, these given equations are of the form vector r is equal to vector a1 plus lambda vector b1. Okay, vector b1, that is the parallel vector of this line. Okay, so, and here vector r is equal to vector a2 plus mu vector b2. Okay, so here b1, vector b1 is 3i plus 2j plus 6k, and vector b2 is I plus 2j plus 2k. Substitute, that is equal to, here vector b1 is 3i plus 2j plus 6k dot b2 is I plus 2j plus 2k divided by modulus of vector b1. So here let's write what are the vector b1 and vector b2. Vector b1 is 3i plus 2j plus 6k. Vector b2 is I plus 2j plus 2k. Okay. Now modulus of vector b1 is square root of 3 square 9 plus 2 square 4 plus 6 square 36 into root of 1 square 1 plus 4 plus 4. That is equal to, here 3 into 1, modulus of 3 into 1 3 plus 2 into 2 4, that is dot product of two vectors. Okay, 6 into 2 12 divided by 49, right? 9 plus 4 13, 13 plus 36 49, square root of 49 7 into, here 1 plus 4 5, 5 plus 4 9, that is 3. Okay, that is equal to 3 plus 4 7 19, right? So 19 divided by 21. So 19 divided by 21, that is cos theta is equal to 19 by 21. Therefore theta is equal to, this implies theta is equal to cos inverse of 19 divided by 21. So it is the angle between these two lines. Now let's find the angle between these two lines. So here also given equations are of the form vector r is equal to vector a1 plus lambda vector b1, vector r is equal to vector a2 plus mu vector b2. And let theta be the angle between these two lines. Then cos theta is equal to modulus of vector b1 dot vector b2 divided by modulus of vector b1 into modulus of vector b2. See, what are vector b1 and b2? See, vector a1 plus lambda vector b1, vector a2 plus mu vector b2. So here vector b1 is equal to I minus j minus 2k. Vector b2 is equal to 3i minus 5j minus 4k. Okay. Then that is equal to, so here let's substitute vector b1 and vector b2 here. That is modulus I minus j minus 2k dot 3i minus 5j minus 4k divided by modulus of vector b1 is square root of 1 square 1 plus minus 1 square 1 plus minus 2 square 4 into root of 3 square 9 plus minus 5 square 25 plus minus 4 square 16. That is equal to 1 into 3, 3 minus 1 into minus 5 plus 5 minus 2 into minus 4 plus 8 divided by 1 plus 1 2, 2 plus 4 6, root 6 into, that is 25 plus 25 50, right? So root 50. That is equal to, here 3, 8, 16, 16 divided by, this one can be root 50 can be written as 50 into, yes, 2 into 25, that is 5 root 2, right? Okay. So here 5 root 2 into root 6, that is 5 root 12. Okay. So here it is cos theta is equal to 16 by 5 root 12. That implies theta is equal to cos inverse of 16 divided by 5 root 2. Sorry, root 12. So it is the angle between these two lines. Find the angle between the following pair of lines. X minus 2 divided by 2 is equal to y minus 1 divided by 5 is equal to z plus 3 divided by minus 3, and x plus 2 divided by minus 1 is equal to y minus 4 divided by 8 is equal to z minus 5 divided by 4. So here given equations of lines are in Cartesian form, right? So here we have to find the angle between these two lines. Therefore, let's write the formula for angle between two lines in Cartesian form. Okay, that is, okay, so first of all let theta be the angle between two lines. Okay, then cos theta is equal to modulus of a1 a2 plus b1 b2 plus c1 c2 divided by root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square. Okay, then here what are a1 b1 c1 a2 b2 c2 are the direction ratios of the lines, right? So here what are the direction ratios? See, 2, 5, minus 3 are the direction ratios of this line, and minus 1, 8, 4 are the direction ratios of this line, right? So let's write a1 is equal to 2, b1 is equal to 5, c1 is equal to minus 3, and a2 is equal to minus 1, b2 is equal to 8, c2 is equal to 4. Okay. Now let's substitute these values in this formula. Okay. Therefore, cos theta is equal to modulus of a1 into a2, 2 into minus 1 minus 2, plus b1 into b2, 40, plus c1 into c2 minus 12, divided by root of a1 square 4 plus b1 square 25 plus c1 square 9 into root of a2 square 1 plus 64 plus 16, that is equal to 40 minus 14, that is 26 divided by, it is root 38, it is root 81, that is equal to 26 divided by root 81 is 9, so 9 root 38. So cos theta is equal to 26 divided by 9 root 38. Therefore theta is equal to cos inverse of 26 divided by 9 root 38. Now let's find the angle between these two lines, second one. So here also let's write the direction ratios of these given lines. That is 2, 2, 1 are the direction ratios of first line, and 4, 1, 8 are the direction ratios of second line. Okay, so we have to find the angle between them. So here let theta be the angle between these two lines, and we will write the formula for angle between two lines in Cartesian form. Okay, so here a1 is equal to 2, b1 is equal to 2, c1 is equal to 1, a2 is equal to 4, b2 is equal to 1, and c2 is equal to 8, right? Then cos theta is equal to modulus a1 into a2, 2 into 4, 8, plus b1 into b2, that is 2 into 1, 2, c1 into c2, 8, divided by root of a1 square 4 plus 4 plus 1 into root of 16 plus 1 plus 64. That is equal to 18 divided by 9 root 9 into root 81. That is equal to 18 divided by 3 into 9, 27. That is equal to 9 2s are 9 3s are. Okay. Therefore, theta is equal to cos inverse of 2 by 3. So, it is the angle between these two lines. Find the values of P so that lines 1 minus x by 3 is equal to 7y minus 14 divided by 2p is equal to z minus 3 divided by 2 and 7 minus 7x divided by 3p is equal to y minus 5 divided by 1 is equal to 6 minus z divided by 5 are at right angles. Okay, so here it is given that angle between these two lines is 90 degree. These lines are at right angles means they are perpendicular, right? That means their angle is 90 degree. Okay, so here then what is the value of P? Okay, so here first of all we have to write these equations in standard form. We know that what is the equation of line in Cartesian form, that is in standard form x minus x1 divided by a, y minus y1 divided by b is equal to z minus z1 divided by c, right? So here we have to write it in the standard form, then only what we will get what are the direction ratios of the line. Okay, so here first of all let's write the given equations in standard form, that is in Cartesian form. So here 1 minus x, here our equation is x minus, that is x minus x1. So let's take minus outside. Okay, so that it will be x minus 1. Okay, x minus 1 divided by minus 3, right? That is equal to, here we need y minus y1, right? So here we have to take 7 outside. Okay, that is 7 into y minus 2 divided by 2p, right? So let's write this, take this 7 here. Okay, that is 2p by 7. Okay, now it's in the form of y minus y1 by b. Okay, that is equal to, next, z minus z1 divided by c, that is 2. Okay, next let's write the second equation, 7 minus 7x. Here our equation of the form x minus x1, right? X minus x1. So here we have to take minus 7 outside, so that we will get minus 7 into, okay, we have taken minus outside, therefore x minus 1, okay, divided by 3. So let's take this minus 7 here, minus 7. Okay, so now it is in the form x minus x1 divided by a, that is equal to y minus y1 divided by b, that is equal to, here see 6 minus z, not 6 minus z, z minus 6, right? Or here it should be in the form z minus z1. Therefore here we have to take minus outside, so it will be z minus 6 divided by minus 5. Okay, then now we will get what are the direction ratios of these lines. Okay, see here, and we know that, see here we have to find the value of P so that these two lines are right angles, at right angles. Okay, so these two lines are right angles means these two lines are perpendicular. Okay, that is, we know that if two lines are perpendicular, then A1 A2 plus B1 B2 plus C1 C2 is equal to 0. Right? If two lines are perpendicular, then A1 A2 B1 B2, A1 A2 plus B1 B2 plus C1 C2 is equal to 0. Here A1 A2, A1 B1 C1 A2 B2 C2 are the direction ratios of these lines. Okay? Now, so here we have to take this equation. So here A1 is equal to minus 3. So minus 3 into A2 3P divided by minus 7 plus B1 2P divided by 7 into B2 1 plus C1 2 into C2 minus 5, that is equal to 0. Okay. That implies here minus cancelled. Then 3 3 9 9P divided by 7 plus here 2P divided by 7 minus 10 is equal to 0. Take this 10 right side. Okay. So 10. Then that implies 9P plus 2P 11P divided by 7 is equal to 10. That implies 11P is equal to, take this 7 right side, 70. Okay. That implies P is equal to 70 divided by 11. The value of P is 70 divided by 11. Show that the lines x minus 5 divided by 7 is equal to y plus 2 divided by minus 5 is equal to z by 1 and x divided by 1 is equal to y by 2 is equal to z by 3 are perpendicular to each other. Similar question, but here we have to prove given equations, given lines are perpendicular. Okay, so here first of all you have to check whether these given equations are in standard form or not. Okay, see here, that is x minus x1 by a is equal to y minus y1 by b, z minus z1 by c. See, given equations are in standard form. So let's write the direction ratios of the lines, because here we know that if two lines are perpendicular, then a1 a2 plus b1 b2 plus c1 c2 is equal to 0. We have to prove this one, right? We have to prove a1 a2 plus b1 b2 plus c1 c2 is equal to 0. Then we can say that given lines are perpendicular to each other, right? So here, so first of all, let's write a1 direction ratios. What are a1 b1 c1 a2 b2 c2 are the direction ratios of these two lines, right? So a1 is equal to 7, b1 is equal to minus 5, c1 is equal to 1, and a2 is equal to 1, b2 is equal to 2, c2 is equal to 3, right? Now let's find, we have to prove this one is equal to 0, right? So a1 a2 plus b1 b2 plus c1 c2 is equal to, substitute these values, a1 into a2, that is 7, plus b1 into b2 minus 10 plus c1 into c2, that is 3. Okay. So 7 plus 3 10, 10 minus 10 0. So we have got a1 a2 plus b1 b2 plus c1 c2 is equal to 0. Therefore, given lines are perpendicular to each other. Next question. Find the shortest distance between the lines vector r is equal to I plus 2j plus k plus lambda into I minus j plus k and vector r is equal to 2i minus j minus k plus mu 2i plus j plus 2k. Okay, here equations of two lines are given. So let's compare these equations with these equations. Vector r is equal to vector a1 plus lambda vector b1. And another equation of, that is vector equation of line, vector r is equal to vector a2 plus mu vector b2. Let's compare these equations with given equations. So here we will get vector a1 is equal to I plus 2j plus k. Vector a2 is equal to 2i minus j minus k. Vector b1 is equal to I minus j plus k. Vector b2 is equal to 2i plus j plus 2k. Okay. So here we have to find the shortest distance between these two lines, right? So what is the equation? Shortest distance is equal to A2 vector A2 minus vector A1 dot B1 cross B2 vector B1 cross B2 divided by modulus of vector B1 cross B2, right? So let's find these things, vector A2 minus vector A1, vector B1 cross vector B2 and its magnitude. Okay, so let's find vector B1 cross vector B2, that is equal to determinant I, J, K, B1, B2. 1, minus 1, 1, 2, 1, 2. That is I into minus 2, minus 1, minus J into 2 minus 2, that is 2 minus 2, plus K into 1 plus 2, that is equal to minus 3I minus 0J plus 3K. Okay, now let's find modulus of vector B1 cross vector B2. Modulus of vector B1 cross vector B2 is equal to square root of minus 3 square 9 plus 3 square 9, that is equal to square root of 8. Okay. Next we need to find vector A2 minus vector A1. So what is vector A2 minus vector A1? Vector A2 minus vector A1, 2 minus 1, 1, I, minus 1, minus 2, minus 3, J, minus 1, minus 1, minus 2, K. Now let's substitute this in this equation, that is shortest distance is equal to vector A2 minus vector A1, that is I minus 3J minus 2K dot vector B1 cross vector B2, that is minus 3I minus 0J plus 3K divided by modulus of vector B1 cross vector B2 is root 18. Okay, that is equal to 1 into minus 3 minus 3 minus 3 into 0 0 minus 2 into 3 minus 6 divided by root 18, that is root of 18. See, this root 18 can be written as square root of 9 into 2, therefore 3 root 2, right? Okay, so we can write it as 3 root 2. Minus 3 minus 6 minus 9 divided by 3 root 2, that is equal to 3 cancelled. So minus 3 by root 2 is the shortest distance. Say its modulus, okay? Because since it is distance, it is positive. It's always positive. Therefore, it is modulus of minus 3 by root 2, that is 3 by root 2. 3 by root 2 is the distance between these two lines. Find the shortest distance between the lines. X plus 1 divided by 7 is equal to y plus 1 divided by minus 6 is equal to z plus 1 divided by 1. And x minus 3 divided by 1 is equal to y minus 5 divided by minus 2 is equal to z minus 7 divided by 1. Here given equations of two lines are in Cartesian form and we have to find the shortest distance between these two lines. Okay. So here in two methods we can find the shortest distance. Say first one, you can apply the formula in Cartesian form, okay, and second method, you just apply, just convert this Cartesian form to vector form, that is vector equation of two lines, vector equation of lines, okay. After that, you can apply the same formula which we have applied in last problem, okay. So here, I think it is better to apply second method because so that you can, it is enough to memorize only one formula, that is shortest distance between two lines is vector B1 cross vector B2 dot vector A2 minus vector A1 divided by modulus of vector B1 cross vector B2. So it is enough to memorize only this formula. Okay. So here it is better to apply second method. That is, you just convert this Cartesian form to vector form. Okay, then apply this formula. Okay. So here, first of all, let's write these equations in vector form. That is, vector r is equal to vector a plus lambda vector b. It is the vector equation of the line, right? Okay. So here let's write vector r is equal to vector a, that is here x minus minus 1. Okay. So minus I minus j minus k, okay, plus lambda into vector b, that is vector of direction ratios. So lambda into 7i minus 6j plus k. Okay. Next vector r is equal to, next equation, 3i plus 5j plus 7k plus mu into here I minus 2j plus k. Okay. Now these are the given vector equations. Okay. Given equations of vector equations of two lines. Okay. So here now let's write vector a1. It is vector a1, vector b1, vector a2, vector b2. Right. So vector a1 is equal to minus I minus j minus k. Vector a2 is equal to 3i plus 5j plus 7k. Vector b1 is equal to 7i minus 6j plus k. Vector b2 is equal to I minus 2j plus k. Okay. So here now let's substitute this here. So before that we need to find vector a2 minus vector a1, vector b1 cross vector b2. So let's find vector b1 cross vector b2. Vector b1 cross vector b2, determinant I, j, k, 7 minus 6, 1, 1 minus 2, 1. That is equal to I into minus 6 minus minus 2 plus 2. Okay. Minus j into 7 minus 1 plus k into minus 14 plus 6. Minus 14 plus 6. That is equal to minus 4i. 7 minus 1, 6, minus 6j. It is minus 8k. Okay. Now let's find modulus of vector b1 cross vector b2. That is equal to square root of 4 minus 4 square 16 plus 36 plus 64, that is equal to 80, 96. Square root of 96. Sorry, it is 100, 116. Okay, 116. Okay. Then let's find vector a2 minus vector a1. Vector a2 minus vector a1 is equal to 3 minus minus 1, 4, 4i, 5 minus minus 1, 6j, 7 minus minus 1 plus 8k. Now let's substitute here. Vector b1 cross vector b2 minus 4i minus 6j minus 8k dot 4i plus 6j plus 8k divided by root of 116. Okay. That is equal to minus 4 into 4 minus 16 minus 6 into 6 minus 36 minus 8 into 8 minus 64 divided by root 160. That is equal to here, that is minus 116 divided by root of 116, that is equal to here root 116 cancelled, so minus, see it is the distance, right? So here we can it is the The formula is modulus because since it is in distance, it is always positive. Okay, so it is modulus. So if you get minus after calculation, see you have to take it positive. Okay, so here 116 root of 116. So 116 can be written as find the shortest distance between the lines whose vector equations are vector r is equal to I plus 2j plus 3k plus lambda into I minus 3j plus 2k and vector r is equal to 4i plus 5j plus 6k plus mu into 2i plus 3j plus k. Here given equations are in vector form. Okay. So let's compare these given equations with the vector equations of lines, that is vector r is equal to vector a1 plus lambda vector b1 and vector r is equal to vector a2 plus mu vector b2. Now let's compare these equations with the given equations. So here we get vector a1 is equal to I plus 2j plus 3k. Vector a2 is equal to 4i plus 5j plus 6k. Vector b1 is equal to I minus 3j plus 2k. Vector b2 is equal to 2i plus 3j plus k. Now what is our formula? Shortest distance is equal to shortest distance between two lines is equal to vector a2 minus vector a1 dot vector b1 cross vector b2 divided by modulus of vector b1 cross vector b2. Now let's find vector b1 cross vector b2. That is equal to determinant I, j, k, 1 minus 3, 2, okay, 2, 3, 1, 2, 3, 1, I into minus 3 minus 6 minus j into 1 minus 4 plus k into 3 plus 6, 3 plus 6, that is equal to minus 9i minus 3 minus, so plus 3j here plus 9k. Okay. Next we will find modulus of vector b1 cross vector b2. Modulus of vector b1 cross vector b2 is equal to square root of minus 9 square 81 plus 3 square 9 plus 9 square 81. 1 square root of 171. Okay. Then let's find vector a2 minus vector a1. Vector a2 minus vector a1 is equal to 4 minus 1, 3i, 5 minus 2 plus 3j, 6 minus 3, 3k. Okay. So vector a2 minus vector a1 is 3i plus 3j plus 3k. Next we will substitute these things in this formula, that is shortest distance is equal to vector a2 minus vector a1, that is 3i plus 3j plus 3k dot vector b1 cross vector b2 minus 9i plus 3j plus 9k divided by root of 171. That is equal to 3 into minus 7 minus 9 minus 27 plus 9 plus 27, that is equal to, here 27 cancelled, minus 27 plus 27 cancelled, okay, divided by root of 171. See, root of 171 can be written as, that is 9 into 19, right? Yes. 9 into 19. Okay. So here 9 divided by, so when we take 9 outside, it will be 3 root 90. Okay. 3 root 90. That is equal to 3 divided by modulus. Okay. So you should write modulus of this. Formula is shortest distance is equal to modulus of vector a2 minus vector a1 dot vector b1 cross vector b2 divided by modulus of vector b1 cross vector b2. Okay. So 3 divided by root of 90. So it is the shortest distance between these two lines. Find the shortest distance between the lines whose vector equations are vector r is equal to 1 minus t I plus t minus 2 j plus 3 minus 2 t k and vector r is equal to s plus 1 I plus 2s minus 1 j minus 2s plus 1 k. See here given equations are in vector form and it is not in the form of vector r is equal to vector a plus vector r is equal to vector a plus lambda vector b, right? So first of all here we have to write this equation in this form. Okay. So for that reduce it, that is vector r is equal to here 1i, that is I. Okay. Next minus 2j, then 3k plus 3k plus here t is common, let's take t outside, t into here 1i, that is minus I, okay, minus t into I, okay, minus ti. So minus t, we have taken t outside, so minus I, here plus j, here minus 2tk, so minus 2k, okay. See now it is in the form of vector r is equal to vector a plus lambda vector b, okay. Then next equation, vector r is equal to I minus j, here minus k plus s into, we have taken s outside, so s into I, so we have taken s outside, therefore here I, then plus 2j, here minus 2sk, so minus 2k. Okay, now we have vector equations of two lines. Then we have to find the shortest distance between these two lines. So for that, let's write vector a1 is equal to I minus 2j plus 3k and vector b1 is equal to minus I plus j minus 2k and vector a2 is equal to I minus j minus k, okay, and vector b2 is equal to I plus 2j minus 2k. Then write the formula, shortest distance is equal to, okay, before that let's find vector b1 cross vector b2, that is equal to determinant I, j, k, vector b1 cross vector b2, so minus 1, 1, sorry, minus 1, 1, minus 2, minus 1, 1, minus 2, 1, 2, minus 2. Okay, these are the vector b1 and vector b2. So here that is equal to I into minus 2, minus 2, minus minus 4, so plus 4, minus j into minus 2 into minus 1, 2, okay, 2 plus 2, 2 plus 2, plus k into minus 2 minus 1, that is equal to 2i minus 4j minus 3k. So next we will find modulus of vector b1 cross vector b2, that is equal to root of 2 square 4 plus minus 4 square 16 plus 9, that is equal to root of 29. Then let's find vector a2 minus vector a1, that is equal to, it is vector a2, it is vector a1, so 1 minus 1 0, okay, 0 I, minus 1 minus minus 2, that is minus 1 plus 2, that is plus 1 j, minus 1 minus 3, minus 4k. Then shortest distance is equal to vector a2 minus vector a1 dot vector b1 cross vector b2 divided by modulus of vector b1 cross vector b2. Okay, that is equal to vector a2 minus vector a1 0i plus j minus 4k dot vector b1 cross vector b2 2i minus 4j minus 3k divided by, it is root 29. That is equal to 0 into 2 0 minus 1 into minus 4 minus 4 minus 4 into minus 3 plus 12 divided by root 29, that is equal to 8 divided by root 29 is the okay. So shortest distance between given two lines is 8 divided by root of 29.